Hello everyone, in this Thierry Sicard tutorial number 50 we will talk about the International System Unit MKSA and more particularly about the end of the use of the standard physical cylinder kilogram since May 20, 2019. The main drawback of this small physical cylinder used since 1889 was the slow degradation over time. It was stored under vacuum and used only once every 2 years to make standard copies. The MKSA International Unit System is based on the 4 main units: M for the distance in meter, K for the mass in kilogram, S for the time in second, and A for the electrical current in ampere. The main goal is to link the 4 main units to a universal constant, but until May 20, 2019, only the kilogram was based on a physical metal cylinder called IPK for International Prototype Kilogram. Before the May 20, 2019, only 3 units of the MKSA system was based on constant. The second was defined by the cesium-133 frequency. The meter was defined by the speed of light in the vacuum, C. The ampere was defined with the electron electric charge, E. This change went almost unnoticed by a wide audience, but since May 20, 2019, the kilogram is based on the Planck constant H. The unit of the Planck constant H is a joule multiplied by the second, which means that the energy is multiplied by time. But as the Einstein relation E equal mc square do a link between energy and mass, the H Planck constant unit can be also in kilogram meter square by second. So we have a relation between the Planck constant H and the mass m. It was a real technical challenge to measure with a very high accuracy this so tiny H Planck constant 10 to the power minus 34. To do this H Planck constant measurement, they used the ampere balance with the first static measure. This balance does an equivalence between 2 forces: a mechanical force P equal mg, where they used the standard kilogram, and an electromechanical force F equal BLI, where B is the magnetic field, L is the coil length, and the electrical current I in ampere. In a second phase, they do a dynamic measure by moving the coil with a velocity V. Then they got the relation E equal BLV, where E is the electromotrice force, B the magnetic field, L the coil length, and V the velocity. As the factor BL is on both equations, the BL factor can be removed to get the equation mgv equal E time I, where mgv is equivalent to a mechanical power and E time I is equivalent to an electrical power. The different parameters V, E, and R was measured with the Josephson effect Kj equal 2E over h and the quantum Hall effect Rk equal h over E square. From these 2 measures, static and dynamic phases, we got the link between the mass m and the H Planck constant. Do not worry, the new kilogram is equal to the old one, because the H Planck constant was measured with the old kilogram. Now, no more MKSA 4 main units are based on real physical element, but only based on physical universal constant. E for electrical current unit in ampere, C for the length in meter, cesium frequency for the time in second, H for the mass in kilogram. On my next Thierry Sicard tutorial number 51, we will come back to the electric schematic series, speaking of RS latch. So see you soon and stay tuned.